harmonic motion, a mechanism such as friction dissipates or reduces the energy of an oscillating system, with the result that the amplitude of the motion decreases in time. Here we discuss the opposite effect, namely, the increase in amplitude that results when energy is continually added to an oscillating system. To set an object connected to an ideal spring into simple harmonic motion, some agent must apply a force that stretches or compresses the spring initially. Suppose that this force is applied at all times, not just for a brief initial moment. The force could be provided, for example, by a person who simply pushes and pulls the object back and forth. The resulting motion is known as driven harmonic motion because the additional force drives or controls the behavior of the object to a large extent. The additional force is identified as the driving force. Here we describe one particularly important example of driven harmonic motion. In this case, the driven force has the same frequency as the spring system and always points in the direction of the object's velocity. The frequency of the spring system is F equals 1 over 2 pi times the square root of k divided by m, and is called a natural frequency because it is the frequency at which the spring system naturally oscillates. Since the driving force and the velocity always have the same direction, positive work is done on the object at all times, and the total mechanical energy of the system increases. As a result, the amplitude of the vibration becomes larger and will increase without limit if there is no damping force to dissipate the energy being added by the driving force. This situation is known as resonance. Resonance is defined as follows. It is the condition in which a time-dependent force can transmit large amounts of energy to an oscillating object, leading to a large amplitude motion. In the absence of damping, resonance occurs when the frequency of the force matches a natural frequency at which the object will oscillate. The role played by the frequency of a driving force is a critical one. The matching of this frequency with a natural frequency of vibration allows even a relatively weak force to produce a large amplitude vibration because the effect of each push-pull cycle is cumulative.